Most tsunami videos begin when a wall of water reaches land. This one begins earlier while the land itself is disappearing. The grainy film is real. It was shot from the freighter China at the Valdez waterfront during the 1964 Great Alaska Earthquake. Watch the distant shoreline. Buildings and dock structures seem to drift, but the camera is not watching an ordinary wave come in. The ground beneath the waterfront is collapsing into the fjord. Water and wreckage are flowing toward a new underwater cliff. U.S. Geological Survey researchers say they know of no other film that shows the formation of a large submarine landslide like this. To understand the danger in these frames, first forget the cartoon version of a tsunami as one giant wave racing across an empty ocean. On March 27th, a magnitude 9.2 earthquake shook Alaska for several minutes. At Valdez, the waterfront had been built on a delta, loose sediment delivered by rivers where the land meets deep water. That sloping pile can look solid from above while remaining vulnerable below the surface. The earthquake did not simply push water toward town. It destabilized the delta front. Later mapping and modeling found that a section about 1,500 meters long retreated roughly 150 meters. In seconds, part of the seafloor and waterfront moved downslope. That sudden loss of solid volume displaced water, while the new depression pulled water and debris outward. The local tsunami was therefore being generated right beside the people filming it, not arriving from a distant source. The surviving action is only about 48 seconds and its original edit was incomplete. Researchers restored the order by matching landmarks, eyewitness accounts, damage surveys, and the movement of the ship. Now the clues line up. First, the former shoreline and dock buildings drop away. A dark edge grows taller across the foreground, the top of the underwater landslide scarp. Water races away from shore and pours toward that drop, carrying timber and wreckage with it. Farther offshore, the surface becomes a muddy boil as displaced sediment and water rise. Then the direction changes. A powerful wave rushes back across the damaged waterfront. The film looks chaotic because several processes overlap. Shaking, sliding ground, water draining into the new hole, debris moving, and the tsunami returning through the same harbor. People often expect danger to look like a wave approaching from the horizon. Here, the first dramatic motion is water moving away. That can invite the worst possible reaction, walking closer to inspect the exposed ground. At Valdez, the retreat was not a harmless low tide. It was evidence that the shape of the coast had just changed. Local landslide tsunamis can also provide much less warning time than a wave crossing an ocean. A monitoring center may detect the earthquake, but the water beside you can already be moving. The National Weather Service therefore treats nature itself as a warning system. Strong or long shaking near the coast, a sudden rise or fall of the ocean, or a loud ocean roar. Anyone can mean a tsunami is close. If you are in a coastal hazard zone and feel strong or prolonged shaking, first protect yourself during the earthquake. As soon as you can move safely, go to high ground or inland, away from the water. Do not wait at the shoreline for a siren, a phone notification, or visual confirmation. Do not return after the first surge. Later waves can be larger and dangerous currents can continue for hours. Follow local evacuation signs and officials once you are safe. This film makes that advice concrete. The people at the waterfront were not watching a distant disaster approach with a countdown. They were standing beside its source. The collapsing dock, the retreating water, and the returning wave were parts of one fast sequence. 60 years later, scientists used this fragment with modern seafloor maps to reconstruct how the slide began and where its debris traveled. Surveys found a chute and huge deposits beneath Port Valdez, along with evidence that similar slides had happened there before. That does not mean every coastal slope will fail, or that every tsunami begins this way. The Great Earthquake also produced tsunamis through other mechanisms. What the film preserves is rarer. The moment a local underwater landslide creates its own wave in front of the camera. So the next time the ocean suddenly pulls away after strong shaking, Do not treat the empty shoreline as the end of the event. It may be the first visible frame of what comes next. Subscribe for more real footage decoded from the clues already inside it.